So now that we're through maps, we're going to get into the actual material that everything that we've been talking about up to this point actually led to, starting with minerals to rocks, to able to put things in order and give actual numbers to their age with relative and absolute dating, going through maps to help justify everything that we're going to see here. But we're working up to a theory known as plate tectonics. All right, today we're going to do something that's very similar to it, known as continental drift. It's a little bit different, but it's something that I'm sure you guys have heard about before. Continental drift basically states that Earth's continents were once joined as a single landmass. This landmass was known as Pangaea, all right, which means all Earth. And 200 million years ago, this single landmass actually broke apart, all right, and began to drift where they are now. It took 200 million years to go from that one large supercontinent known as Pangaea to where they are now. So it's very slow. It's why you don't feel it. All right. And this theory, known as continental drift, was first described by Alfred Wegener. All right. The first bit of evidence that he came up with, and people before him actually noticed this also, is that certain continents look like they're actual puzzle pieces. And I would direct your attention to South America and Africa. These guys are the most obvious. All right, they do look like they could fit together. In fact, previous scientists suggested that possibly the southern continents were formed together in a sub-supercontinent known as Gondwanaland. All right, but Wegener actually knew that all of them were once put together. And this picture off to the right here is just a true aerial view of the Red Sea. And you can see how it looks like it could easily fit back together. The Red Sea is in between Africa and the Arabian Peninsula, and it actually is splitting apart. All right, but Wegener took it farther than his predecessors and didn't just look at maps. He actually came up with large rocket formations to help support his evidence or his theory, fossil evidence and climate evidence. And this stuff had been around before, but he was the first one to tie it all together. All right, so not only did he have those puzzle pieces, but he also had evidence in the rock formations, large rock formations like mountains and mountain ranges, excuse me. So the best one that we can look at are the Appalachian Mountains. All right, the idea is if all the continents are once together, then maybe there are things that span across it, like large mountain ranges. The Appalachian Mountains are very old, and we know they're very old just by looking at them. They're very worn down compared to the Rocky Mountains that are very sharp and tall, snow-capped mountains. The Appalachians are smaller. All right, they actually were very tall. In fact, I've heard in the past that they could have been as high as the Himalayan mountains with Mount Everest, but through millions and millions of years of weathering, they've actually been worn down to where they are now. So the idea here, again, look at the Appalachian Mountains. You can see that they're here in North America. And if you go across the pond, all right, across the Atlantic Ocean to the British Isles and in Scandinavia, we find similar mountain ranges that of similar age, similar types of rock layers. And what happens if you take these continents again and use them as puzzle pieces and put them together, lo and behold, those three separate mountain ranges actually turn into one mountain range that was split apart as the continents drift apart. Same age, same types of rocks, and they line up perfectly if you put them back together. The next bit of evidence that Alfred Wegener used to support this idea that continents were once together and then have been slowly drifting apart over the last 200 million years is actually something paleontologists were struggling with for decades before Wegener's revelation. What we find is that there are identical species of fossils found from before Pangaea broke up on different continents. And nowadays, obviously, Pangaea is no longer together, and there are these vast oceans in between them. So we don't know how these fossils could have possibly gone over there. All right, they couldn't have swam. Maybe some of the plants' seeds could have floated a small distance, but we find them in weird places. We find them on multiple continents. So it's hard to just figure out what could have caused these fossils to be so widely distributed. A good one that we'll look at here is the Glossopteris fern. The Glossopteris fern is a fern tends to be found in more tropical locations, and it's found in South America. It's found in Africa and India, and Antarctica and Australia. So very widely distributed. Another one is known as the Paradoxides trilobite. The Paradoxides trilobite was a freshwater trilobite that not only showed up in Europe, but also shown up in America. Now, the fact that it's a freshwater trilobite means that if it were to try to swim across here, it couldn't, because there's a saltwater ocean in between. So there's no real good way that it could have possibly gotten across. All right. So a couple ways that people were trying to sort out how these fossils were distributed. Some say maybe it was rafting. All right. So things floated from one spot to another. That could explain a few of the things, but definitely not the large land animals that could not have been carried or floated or even swam. Island hopping. All right. Again, that might explain some things, but there's no way that they could possibly island hop across the Atlantic Ocean. One that held a little bit of credibility is, they call it isthmus link on this cartoon, but it's also known as land bridges. In the last ice age, the ocean's level dropped as the ice was on the land. And across the Bering Sea, which is very shallow, it actually became shallow enough that it was a land bridge. And large mammals and humans actually were known to walk across this from Asia into Alaska and North America. So this is possible, but to have them throughout all of the oceans, across the Atlantic, connecting Europe and America and South America and Australia and Africa and Antarctica, that was a little hard to believe, but people were putting out these ideas because to them in the early 1900s, the idea that continents drift was completely radical. So Wegener, when he took these fossils into consideration and the idea that what would happen if the continents were together, made much more sense. You can see that when you put the continents back together, it's easy for these large land reptiles that could not have possibly swam the distances to easily walk from one spot to the next, because again, this was all one large continent. Glossopteris fern, same thing here, just spread these large reptiles and whatnot. Easily, if it's just one big continent that then was broken apart, makes more sense. All right, so and another bit of evidence that we have here, and I think this is the last one, is climate evidence. So a couple different things here. We find different kinds of sedimentary rocks, and those different sedimentary rocks tell us things about the environment which they form, which is why we went through that stuff so long. All right, first off, certain fossils form, certain rocks form in different situations, such as coal. We usually find coal, if you think back, is made out of plant materials that's been compressed and heated, and it changes a little bit. Well, that kind of environment that you find coal form in starts out as a swamp, big, humid swamps. And, well, what we do see is we find coal deposits in Antarctica, which is really odd to think about. All right. Antarctica is definitely not a place where you would expect to find swamps. So why would there be coal beds? And this is a picture of the coal beds that we find in Antarctica in some of their mountain ranges, unless Antarctica was one time much warmer. Secondly, if we look down here, all right, in places we would think to find that are now tropical, we find actual evidence of glaciers. And let me explain what this picture shows. This picture is showing glacier striations. All right, when glaciers move, all right, there are pebbles underneath and large boulders underneath the glacier that actually get pushed down and rubbed across the rock, and it gouges these big deep lines in it, and those lines indicate direction of motion. So when we see this evidence, we can know that there is a glacier, and we can actually know in what direction it moved. And we plot those out, we find some weird things. In places that are very tropical now, Australia, India, Africa, South America, and obviously Antarctica, which you'd expect to find glaciers, we see that there's glaciers. The odd thing, though, other than the fact that it's nice and warm, is that these glaciers, the direction indicates that it's coming off of the water onto land, and that really does not happen very often. All right, it's much more common to have glaciers go from land to water than to water from land, or from water to land. So it's very odd with the direction, but when you bring all these continents back together, now it makes a lot more sense that it was a large glacier sheet that's spread out into these places from Antarctica and South America area. So it sounds like a really good hypothesis. It sounds like he's got it backed up well, but there are a couple things that he could not do well. His theory was actually rejected by pretty much all scientists, except for some paleontologists, because he could not properly describe how the continents moved, all right, and what their cause was. The two big mistakes he had was, first, he proposed that the continents were like snowplows through the ocean crust. So if you ever seen a snow plow, all right, the plow moves, and as it moves, it pushes the snow off to the side, and that's what he expected the continents to do. As the continents push through the ocean crust, all right, the ocean crust would be pushed aside and crumpled, and we just don't see that. All right, we don't see the ocean floor as being crumpled. It's actually extremely flat. Secondly, what would possibly be causing this snow plow to push through it? Wegener proposed that it was the tidal forces between the Earth and the Moon that caused that. Well, if that was the case, you'd have to have a force that's large enough to actually stop the rotation of the Earth. So first, he couldn't describe it properly, and the cause that he suggested was not physically possible. So eventually, this theory somewhat faded, and he died in the 1920s, I believe, going through trying to find more evidence. What you guys are going to be doing next here after this is going through a lab or two that actually starts to come back to this idea and to modify it and to build more evidence to support the idea that continents do drift, just not in the way that Wegener proposed.